Okay, looking at question 23 from the 2009 HSC Chemistry exam, the graph shows the variation in the concentration of reactant and products as a function of time for the following system. We've got a graph, and what we need to do is identify and explain each of the changes in conditions that have shaped the curves during the time the system was observed. So the marking scheme gives us, we have 6 points, 6 marks, and so we have these verbs identify and explain. Okay, and we've got, we can see these 3 times where changes have begun to occur. So to get the marks, by just identifying these changes, all 3 changes will get you 1 mark. If you identify, say, the first change and are able to explain it, that'll get you 2 marks. If you can identify and explain two of these changes, you'll get 3 to 4 marks. And if you can do it for all 3, you'll get 5 to 6 marks. Okay, so just simply starting out to identify and describe. So I've split the question into sort of parts, and we'll have we'll identify and describe at each time separately. So we start with the change that occurs at 4 minutes. Okay, so what can we see taking place at 4 minutes? We can see that the reaction is shifting to the right. How can we see that? Well, we've got increasing concentrations of your products, okay, which are on the right. And you've got a corresponding decrease in your reactant. Okay, what you do notice as well, there's no sharp or abrupt change in concentration. These changes occur gradually. So that indicates that we've got a change in temperature. So just continually on with describing the changes, what did I say? We've got, there's a gradual increase in the concentrations of the products. You've got the corresponding gradual decrease in the reactant, and you've identified that there's no abrupt changes in the concentrations. So that's indicating that we've got a temperature change. So that's starting to explain it now. So if we go to our options here, because there is only gradual changes, that is no abrupt changes, it indicates that there's a change in temperature. So when you get to this point, okay, we're talking about change in temperature, we need to go back to the equation and identify that it is an endothermic, because it's delta H is positive. So this is an endothermic reaction, which means it absorbs heat in the forward direction. So how do we get an increasing concentration of the products? By adding heat to the system. So if you add heat, according to Le Chatelier's principle, it's going to counteract that increase in heat and drive the reaction in the direction that absorbs the heat. So that's evidence here on the graph. Okay, so our options here would be the reaction is endothermic in the forward direction. Okay, so according to Le Chat's, an increase in temperature, which is addition of heat, will move the reaction in the direction that absorbs heat, which is to the right, and this is evidence in the graph. Okay, so if we look at the equation, I've scribbled it up here, but a nice little equation, nicely written to show this. So adding heat to an endothermic reaction drives the reaction to the right. Sorry, this this endothermic should be over here. Okay, it's just dropped down a little bit. Okay, so adding heat drives the reaction to the right, and it's all got to be evidence in the graph. Okay, so now we'll look at what changes occur at 10 minutes. We can see on the graph that we've got an abrupt decrease in concentration of one of the reactants, carbon monoxide. So effectively we've removed carbon monoxide. So according to Le Chatelier's principle, if you remove one of the reactants, the system wants to counteract that change and replace it. So it wants to drive the reaction to the right. And this is evidence here on the graph where you've got this corresponding increase in concentrations of the products with the gradual decrease in concentration of the reactant. So if we go over here again, we've got what occurs at 10 minutes. There's an abrupt, and this is identifying, describing, there's an abrupt decrease in carbon monoxide. This is followed with a shift in equilibrium to the right. We've got the production of chlorine gas and carbon monoxide. Okay, now explaining that, as I've said, according to Le Chat's, if a product is removed, the system's going to adjust and it wants to replace what's removed. So this is leads to a shift to the right of the reaction. Okay, equation-wise, we can see here, this one sums it up nicely. So we've got removal of a product will drive the reaction to the right. Finally, we've got a change that's occurring at 14 minutes. We can see from the graph that there's an abrupt decrease in the concentrations of all species. So this decrease in concentration of all species indicates that there's been a volume increase on the system. So a volume increase leads to decreased pressure on the system, or decreased total pressure. Okay, so if we've got at 14 minutes, we're identifying what's happening. So at 14 minutes, there's an abrupt decrease in both reactant and product concentrations. We can see after this initial change, there's a shift to the right again, which is this gradual increase in the products, okay, with a decrease in concentration of the reactants. Okay, so there. Now, to explain this, as I said, we've got an increase in the volume of the system. So this has caused the concentration of reactants and products to decrease rapidly. And an increase in volume corresponds to a decrease in pressure on the system. So if we relate this to Le Chatelier's principle, okay, and when we're talking about total pressure, we need to look back at the equation, and we can see on the equation we've got all gas species. So on this side we've only got 1 mole of gas, and on the other side we've got 1 mole plus 1 mole gives you 2 moles of gas. So if you decrease the pressure on this system, it wants to drive in the direction that's going to counteract that decrease in pressure. So the direction that would do so is to the right, where you've got a greater number of moles of gas. Okay, so summing this up with relating it to the equation, we can see 1 mole of gas one side, 2 on the other. An increase in total pressure is going to drive the reaction to the right.